remembering what the outside world was like. So just, I think it's in the chat anyway, but what we're going to need for this workshop is Windows 10 Pro, Enterprise or Education. Docker will not install on Windows 10 Home. If you've got a Linux or a Mac equivalent, then that's fine, but you need the Hyper-V in order for it to be able to display. We'll need a command line editor, a text editor, and then also Postman, and it would be good to have an ID like IntelliJ to run some things as well. So I'll go through the installation of Postman and Docker as we go. So let's get started. Testing in a CI/CD pipeline. Just as a bit of a brief overview as to why we might want Docker in the first place. So continuous integration, continuous deployment pipelines. What they need, or what they are very quick ways of making small code changes continuously in order to de-risk having these big bang kind of deployments to systems. Smaller deployments mean that they're less risky because less gets changed. And in order to get fast and reliable feedback for the code changes that we make, we need automated regression tests as well as good manual testing, but we need regression tests that are going to give us feedback quickly, repeatably, and reliably. And what we tend to find is that in environments where we have really big test environments, where we have to build up and spin up things, we're not able to get fast, repeatable, and reliable information. Now, what that looks like is monolithic environments. So what I'm talking about is your regular huge test environments take a long time to build. They tend to be reliant on up and downstream services that may or may not be in your remit to keep maintained. They have persisted test data. So test data needs to be cleared down or rebuilt each time, or isn't in a good position for us. Tests tend to be run one at a time because they mimic very realistic environments. And what that tends to result in is a situation where we bundle up a load of code changes and throw them all into our big test environment because we don't want to have to keep building it because it takes so long. The way to fix that is to have containers because they're faster to build. We can stub our unused services. We can spin up new data each time we build very quickly so that we've got a known state for running our automation tests. We can parallelize our tests. And they're really good, not just for big bang testing, end-to-end testing, but they're great for unit service integration level tests as well. So it's just, they're just quick and easy little like little virtual machines that we can run a service in rather than a whole big environment. And what they tend to look like is this. We tend to have our apps will run in a container, so like a service. We add those to a network to allow them to talk to each other. And they're all hosted on one or multiple platform nodes. So you'll have your big platform node, your big sort of like Docker. You'll have little networks within that and then little components. And those are all run by an orchestration tool. The reason we have an orchestration tool, something like Kubernetes or Docker Compose, which is something we'll go into, is because we don't want to have to hand crank all of this. We want to automate it as much as possible. Now, this diagram only shows one node, but in reality, you're going to have lots of different nodes, and networks can be configured to run between the different nodes, and they will all be managed by your orchestration tool as possible, where possible. And again, I'm showing really simple architectures there, but you can have multiple services running and connected to each other. Some of those services can be injected data, they can be stubs, they can be little test harnesses. They don't have to be actual tested code. And the reason I'm talking about Docker primarily for containers is because they're open source, meaning that anyone can contribute to or extend the tool. They're comparatively lightweight virtual machines compared to other types of virtual machines that can run Windows and Linux containers. So they're system agnostic. They're really supportable. because they're just so much in vogue at the moment, there's a lot of stuff out there. There's a lot of images that you can use and a lot of support for getting use with them. And there's a lot of different cloud container platforms available for these platform nodes. So there's things like Docker Desktop, Kubernetes, Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, the Google one, IBM's got some, Microsoft Azure. It doesn't really, as a tester, it doesn't really impact us as to which tool is being used. They mostly just are hosts that provide processing to run your little infrastructure on. Some are slightly easier to configure than others. If you've got Kubernetes ones, you can flip between them. But for the most part, it's just who do you want to give money to? That's the main thing there. So that's a bit of background as to what it is and why we would use it. But let's get involved and actually start installing things together. So I'm going to start running through some steps, show you how we get, and then we'll start using Docker. So firstly, we're going to open docker.com and click Get Started and download Desktop for Mac and Windows, which looks like that. So pretty simple. Docker.com, click Get Started, and download for Windows or Mac. And what it's going to do is it's just going to run a little exe there, which will then open up. So it's going to take a minute, and apologies that some of this is going to be watching some installations happening, which is the exciting content that I'm sure you've all joined up for. Actually, yes, Rancher is another multi-cluster orchestration platform. There's loads of them out there. When I talk about it, I mostly talk about things like Docker, Kubernetes, because they're just the biggest ones. They're the most supportable. So if I'm talking about integrating these things into a new team, let's use the most supportable ones. Let's use ones that we can easily get information about. So they're the ones that I usually talk about, but there's loads of them out there. Quick Google will show you loads of the things. So that should be installing. And just a note here that I've put in. So the machine running Docker needs to support the running of Hyper-V virtualization. Windows Pro and so on, Windows 10 Pro will have that set automatically. So some troubleshooting, if it's not working, is to go to the machine's BIOS, and that's the F2 when you first start up the machine, just to make sure your Hyper-V virtualization settings are set on. It's also the reason why Docker won't install onto Windows 10 Home, because that Hyper-V virtualization isn't available on that. So if your network is like mine, you should be soon coming up to getting the Docker running. And whilst we're waiting for it to install, what we can do is we can start to sign up to make a Docker account. So that's something we're going to need to do as well. So if you scroll back up and click sign in up here, and then either sign up or sign into an account. It's just on-screen instructions. You can click sign up there. It's really simple to do. You'll just have to ping yourself an email to validate it, but that's pretty much all you've got to do. Once we've got the installer going, in fact, I'll give you a little moment just to do the sign in. If you ping in the chat if I'm going too fast or too slow, let me know, because I can adjust. So once we've done the sign in, I'll just click on the sign in. It gives us a page like that. This is Docker Hub. You can configure all sorts of things from your profile. It's all free, so nice to use. And then when we've installed the exe, just click on it, or go to your downloads folder to click on it. And then I remember that my machine has got a thing going on it that won't allow me to install things unless I'm in a different folder. Yep. So we're going to go to downloads, take that. Pop that in there and then open it. Sorry, that was just me having to type in a password quickly, and it's going to give you a little ID, like a little, not an ID, but a little installer. So pretty simple, and it will just download. And you just click next a lot. Basically, it will look like this over here. So uncheck both the options. We don't need desktop shortcut. We don't need Windows containers, and then just click close when the installation has completed. It might require a restart. You can see I've already got it installed here, so it's asked me if I want to do an update. So I'm just going to click no. So I've already got it installed. Have people managed to get that far? Give me a thumbs up in the chat if you have. Cool, not yet, I'll just wait. Okay, got a few yeses. I'll move on to the next slide. So from the start bar, you just want to run Docker desktop, pretty simple. When you click on it, it may do an update. You can do an install update if you want. If you do the update, you'll have to reopen Docker desktop from the start bar again. And when you do load it up, what you'll see is a little Docker icon in your system tray like this. And then if you right click it, there'll be a sign in or create Docker ID. They'll pop up a little window like this, and you'll be able to sign in. And then when you've signed in, just give me a sort of a feeling on when people have managed to do that, because the next part will be having it running. Great, that's good. That's good, Shay, because that means my steps haven't been that terrible. Cool. Okay, so that's the installation thing. So congratulations, you've installed Docker Hub. We're now able to run Docker on our machines. Pretty simple, just a sign in and a install onto a machine. So next up, we'll go through some basic Docker commands just to get familiar with it. So what Billy will do is he will also share in the chat some of the commands, but if you want to type them out just to get more familiarization with them, that's cool. I'll have them on the screen. If you want to copy paste them from what Billy's saying, just for speed, then we can do that as well. So if you go to your start bar and open Windows PowerShell or a command line or whatever you want to run from, we can do our first command, which is to confirm that Docker is running by using docker -v to display the version of Docker that is running. So that's docker -v for version. So, and I think you can do that from anywhere. There we go. So that's my build there. You can see that. And once we've seen that there's a version, we can validate the installation by running a little Docker container by using this command, run hello dash world. So again, this is where I then realized it should have been Docker run. Sorry about that. Yeah, so ignore what's on the screen there. And when you do run hello world, put Docker in front of it. Sorry, that was my mistake. I didn't highlight it there. So that was a formatting error. But yes, Docker run hello world. And you'll see here, hello from Docker, and this will show everything's running. So when you've done that, you've basically run your first Docker instance, which is great. And the first time that Hello World is run, it's going to pull and install that image. And what an image is it's effectively a little snapshot of a virtual machine that's just online. And what Docker can do is it can go find those and pull them and install them for you. And it's not just true for Hello World. It will find and install any valid images that are not already deployed to your machine, so that you've got those for use in the future. And it will only work if you're signed into Docker. So you have to sign in to Docker Desktop. That's why we did that. So next up, so Docker run is the command that we're going to use to run processes in isolated containers. So it takes the form of Docker run options image. So to see all of those things, we can do Docker run -- help, and that will give us lots of options available to us. Docker run -- help. And you can see loads of different things. I'll go through some of them as we go through. I'm not going to go through all of them, but we'll go through and show some of the useful ones. So the first thing we want to do is we want to open an interactive sudo terminal by pulling an Ubuntu image. So we're going to run Docker run -it for initialize terminal Ubuntu. And it will then show us the container directory, which will look like a little Linux thing. So Docker run -it Ubuntu. And for anyone, so there you go, you can see, couldn't find it locally, it's putting it. And just in case anyone doesn't know, Ubuntu is just a form of Linux. It's just a type of operating system. It's just the type of terminal that we're running. So there we go, we're now in the root. So you should see this little root thing, effectively. If you type in ls, it will show you like a load of folders, which is pretty cool. And then when we want to leave that, we're just going to type exit. And it will take us back to wherever we sat. So to aid with our container management, one cool thing we can do is we can name our containers. So we can append --name into the command. So we do Docker run -it --name, whatever you want to call it, Ubuntu. And that will give us a name to the container. It will help us to know what they're running when we list them out effectively. So let's try that now. So I press up just to get my old command, and I'm going to do --name test _Callum. So that's opened. Rather than exiting out this time, because I want to show you the names of the containers, what I'm going to do is I'm going to press Control and P and Q all at the same time to go back to my hosted machine. So rather than exit will close the container, this will just come out of it effectively. And it's a bit tricky to do, but if you hold down Control and then do PQ, you'll come back. And then once we've done that, and you can see that you're in the Windows line again, if we do Docker PS, it's going to show us, there we go, there's my name, Test Callum. And we have a container ID, which is automatically generated. We have an image, which is the Ubuntu image that we downloaded. Says when it was created, how long it's been up for, what ports it's running on, and then the names. If we don't give it a name specifically, it will just start coming up with names. It's usually 2 different nouns combined with an underscore. It's worth noting, I think for the names, it's alphanumeric and a few special characters are allowed. but rather than have the random ones, it's good to set your own names up so that you can follow them. So has everyone got there? So everyone created some terminals and named one? Can you give me, yeah, cool. That's good. No, no Shane, okay. Is there a step missing for you, or just do you want to give it a sec? I can go back a slide if you wanted to see what the command was. Unknown flag, interesting. Thank you, Isabel. That's a good point. Thank you. Unknown flag on dash dash name. Have a look. So when you did it look like docker run dash it dash dash name, then a space and like that, and then you put in the type of image Ubuntu after it. There we go. Yeah, so first of all, so just following the chat there. So when you do it, you have to do dash dash name and then put in whatever name you want. So there's a command for I'm naming this, then you put the name in, and then the name of the image. So docker run, initialize terminal, name it, here's what I'm going to call it, and then here's the image I'm going to run. So that's how that works. Cool. So just moving on. So in order to then come into things, is we're going to do attach your the name of what we've just created. So I'm going to do attach, and again it's Docker. Sorry about that. So Docker attach Callum _test, and that's going to then put me back into. Oh, why is that not? Oh, because I named it something else. That's why test Callum. There we go. And that's going to pull me back into my little Docker container. I could use the ID. So when we have that list, you see the container ID that's here, which is 6BA7. It's easier to use names because they're just easier for people to parse. So it's easier. That's why we use names rather than IDs. But IDs will work if you want to try and use them. And we'll see this root again. If you do ls, it will show you your Linux system. And if we do the control and P and Q to leave again, control P, Q, and go back to Windows. So that's how to come in and out of a terminal. And if you want to then close the terminal, we're going to use a command. And again, my highlighting is terrible. Sorry about that. Docker rm for remove, -f for force, and the name of the terminal. You can use the ID again if you want to, but it's easier to use the name. So we'll go into that. Docker remove -f test _Callum. It will do that. It will put the name up again to show that that's happened. And once we've done that, we can go docker ps. And docker ps is that command that we used previously that gives you the list of which things are running. So you can see that I no longer have anything running, whereas I did previously. So that's that docker ps command. Cool, so that's how to get into and out of. So now we know how to spin up a name, come into and out of, and close terminals. So let's try using something in reality. I've pulled together a little program for us in my GitHub. So if you navigate to a dev folder, a folder that you don't mind putting something into, I use c/dev quite a lot. So we're just going to do a cd and then c/ whatever you want to call it. Or you can just do cdc if you want to have it there. I'm going to do it into dev. And then we're going to do, you don't need an account for this. I've been reliably informed and when I tried it, but you're going to do a git clone. So here is my repo, git clone, https, github.com, Callum Akehurst-Ryan, dockerpractical.git, and that will just install into the folder location that you've cd'd to. So there should be a link to that because it's quite a long one. So you can see I've already got it installed, but all you've got to do is git clone and then that address. And what it will look like Docker Practical, it should look like this. So it shouldn't take too long to run. Have people been able to find that? Cool. So what we'll see here is we've basically got a normal development repo for a website with a bit of CSS and some images, and this thing called a Docker file. The Docker file doesn't have an extension, and we add it into the same location as the application that we're using for testing, because Docker, when we try to run this thing, is going to look for, in the top level, a Docker file, and then build everything relative to its position. So let's open it up with Notepad++ and have a look what's in there. So when we look in the Docker file, what you can see here is 2 lines of command. The top line here, from, is basically, right, what I want you to do is go and get me an image, an Nginx Alpine image. And then from that image, when you've got the Docker container, is copy dot, so copy everything in the same file location, Docker Practical, into a folder, user sur, Nginx HTML. So all of that will basically go into this file location. So what it's saying, open a Linux Alpine container, copy the current folder into a new HTML location. Was that a question? No, cool. So just to go back quickly, I've created this for you. When you're creating your own environments, you just have to create your own Docker files, and they're quite easy to do. You just create a new, create anything basically, like a text document or a like that. Take all of that out and just do Docker file. Make sure it doesn't have any like .txt or anything after it. Cool. So let's build it. So we're going to go from PowerShell again, and we're going to go into the Docker Practical. So do cd, C, wherever you've put it, Docker Practical. So C, Docker Practical. Oh, that's a semicolon. Didn't want that. So once we're into that location, we're going to run the command docker build -t Docker Practical. And that -t there means Docker build, start in a terminal, Docker Practical, and then dot. And that means everything that's in the current folder. So everything that's in Docker Practical, do that. So let's build it. Docker build -t Docker Practical dot, and where that dot is, that's where it's expecting to find the Docker file. So it's going to do a big build for us. Successfully built. So what it does, you can see here, it finds the steps in the Docker file. So it goes, okay, step 1 is go get me Nginx Alpine. It will probably do an installation of that for you. And then it's going to say, right, I've created that. That's the idea of it. And then step 2, copy that all into it. That's done. and then it will say, okay, successfully built. So when you do a Docker build, it goes and finds that Docker file and executes the commands in there. So once we've got that, we can start running the application. So what we're going to do is Docker run, and then we're going to go -d to run in the background, and then we're going to do -p to set ports, and that's 80 to 80, and then name it, and then what we're going to run, which is this Docker practical build that we've just built, because we've built an image in this step here. So Docker run, we've seen before, -d is just run it in the background, -p is a new command, that's the ports, and we're just going to map them out. And then we're going to do the name command. So if you just follow that, and if you call it test1, it'll make it easier for the copy pasting later. So let me try that as well. Boop. So that should have done. Oh, I've already used a container. So you can see I had a conflict where I have one that's already called test1. So what I'm going to do is I'm just going to call it test A. There we go, and that's it running. So what we should then be able to do is if you open an instance of Chrome or any browser and go to localhost 80, you should see hello Docker like that. And that is something that you have run yourself. So locally, you've run a Docker container and you run an application, a website in that container. So congratulations, that's the basics of starting to use Docker. We've actually got through that a lot quicker than I thought we would. So I can either continue on and we can do a bit of testing with Docker, or I can answer any questions that people have at this point. So do you need to run any of the Nginx stuff to make any of this work? That's a good question. So that's for that specific development. So I was basically trying to run this HTML page using Nginx. So there was an image for it already, and I just basically copied it. So you don't need Nginx. For this instance, you do, because that's basically just the application that's running. But different things that you build are going to use different things completely. I'll come back to you, Rebecca. I'll just ask Shay, is it HTTPS localhost 8080 that I need to run? It depends what you've set on your port configuration. I set it to just 80. So when I looked at it, localhost :80, and that's what comes up. Because when we did the command for here, we set the port to from 80 to 80. We just mapped it to 80. So when you run it, you could set that to anything you want, any open port, and then you'll be able to do that. Cool. Rebecca, so let's look at the from copy again, just to make sure that you've got that. So this is this. So when you've pulled everything from the Git clone, you should have a folder like Windows Dev Docker Practical like this. And in here, we have a Docker file. The Docker file is a file that tells us how to build our Docker image for this application. So in this instance, I've created it for you. And what it is, it's a little file, if I open it again, that just has a series of instructions in it. So when I tell Docker to build and run this folder, it looks for the Docker file. And in there it says, okay, what do I need to do? Okay, go pull me and create me a Docker image of a Linux environment. So this is an Nginx flavor on Alpine, which is a type of Linux. So this is just a virtual machine. So create me a virtual machine, a Docker container. Once I've done that, the next step is copy everything in this folder into the new virtual machine. So all we're doing is start my machine, copy everything into it so that then we can build and run it. So that's what we're doing there. Once we've done that, we go back to our command line. We navigate to it where we've just pulled down the application by saying cd change directory to the location. And then what we need to do is build the image and run the image. So firstly, we build the image and we just go docker build a terminal, and then the name of the terminal that we're going to call it, Docker Practical, and we're going to put dot. Dot is where the Docker file lives. So we're saying, Docker, build me a new terminal called Docker Practical from this location. This is where the Docker file is. And once we've done that, we want to run it. And we basically say, okay, Docker run, and ignore everything in the middle there. Docker run, Docker Practical. So the Docker run, Docker Practical is the name of the image that we gave in the previous step. So that's that. And then everything else is in the middle there is configuration. So we're doing Docker run, and then you see -- name, whatever we want to call it. And that's just the name of the terminal that we're running. So we've done that in the past. So Docker run, call it test1, and run the image Docker Practical that we created there. And then these other two bits here are -d is just to run in the background. I'm not really fussed about being very verbose or anything. We can ignore that if we want to, but I've added it in. And then the P is setting your ports. The reason we want to set our ports is just so that we can find the application once we've run it. So you can set that first number to whatever you want it to be for using the localhost port. And the second number is the port exposed on the container. So you could set this to -p 50 to 80, and then you could look up localhost :50, and then that's where you'd see your website. Were you able to follow that time, Rebecca? Brilliant. Good, good. No, it's good to ask that question because I was able to give a bit more explanation. Can we see the container logs? Potentially. Not something that I know where to find for these ones off the top of my head, but I can look into that and come back to you about that. But yes. Any other questions, or shall I crack on with the next bit in preparation for the next part? I'll take that to crack on. Cool. So the next thing we want to do, really, now that we've got Docker, is we want to use it for our testing purposes. They're little test environments, really. They're little applications that we can quickly spin up and use for testing. So let's try out some of those things. And the first thing I'm going to show you is using Postman. Postman has an image on Docker that we can use. So we're going to add Postman to Docker and point it to an existing web deployed API and test it in the cloud. That way, we don't have to have we don't have to have Postman installed to our physical machine when we're running it, or at least when we're actually running the test. We do have to configure it initially through Postman. So let's get started by going and finding Postman. I'm going to make an assumption that not everyone has Postman installed onto their machine. So firstly, let's go to Postman, and then you just have to click download the app, click the download button, and open the exe file once it's there. And when it's installed, follow the on-screen directions to create an account or to log into the account. And that's going to take a few minutes, so it's good that we do this before next session. Now, for those of you that haven't used Postman before, Postman's just a tool that's really handy in testing. It allows you to send requests to different APIs and get responses. It's a really handy thing. It also has a really nifty feature that allows you to set up tests within it. so that you can automate out some of these API tests. When people are getting started on their automation journey, rather than teaching them to use a programming language or an IDE or something like Selenium, I advocate that they get started with Postman, because Postman can be used manually. You can hand craft your requests. You can then port them into being tests that you can rerun and save. It also comes with a load of really handy little test snippets that we're going to have a look at as well. So it gets you started. And when you want to test layers between your communication of different services or your front end and your back end, like APIs are the way to go. So it's a really good tool to be using at this point. So that's my little plug for Postman. I don't know about speed. So how's everyone looking on their downloads? Is it going? Have people managed to get it logged into it, get it installed? Good to see people have it installed already. It was one of the prereqs. Cool. In which case then, lots of people say they have it installed. I'll go to another step then. So what we're going to do is we're going to create a new collection. So open Postman. So if I open it up, let me close these off quickly for us. So click new collection and just name it. You can give it a description. And click create. And then that will appear in the side over here. So, and then within there, we're going to click new and request. So with that, new request. And we're going to call it whatever we want to. And then pop it in your collection. So you see here, I'm going to click on that, and then it comes up there and save to clan test. There we go. So we now have a new request. Then when we've done that, we're going to click this save button over here. And that'll give us a nice set of a nice request, basically. Right, lots of copy and pasting on the next slide. So here we go. In the new request, we're going to set to get and get this endpoint. This is a publicly available API used for testing. It's called Swagger Pet Store. It lets users post and get details from a hypothetical pet store application, and it's just for practice and testing purposes. If you want more details about it, you can go to https://petstore.swagger.io. It's good for practicing using APIs. So we're just going to take this from Billy there, copy it. We're going to go get and paste it in there. Boop. And then the next thing we're going to do in the test windows. So I need Billy, if you could copy this bunch of text for us. So these are some tests that I've written using the test section of Postman. We're going to put them into, so I'm just going to copy this quickly. So we're going to click tests and pop in that stuff. And that top link there, that bit there from Billy there is just cut off. So what we need to do is just make sure that that is like that. So it starts with /#. So we should have a couple of tests in there. Now you can see, just very quickly from a Postman perspective, there's loads of different snippets here down the side. So they've given us lots of different little tests that we can build and use up if we want to. So have a play with that in your own time. But for now, let's just make sure that this works. Click send, the big blue button here. And what you'll see is some test results, and they've all come back as pass. So this is how we would manually set up and create some tests for using in Postman. But what we want to do is we want to make them accessible to our Docker containers. And just as a note, everything else can be left as defaults. So to use them in the test, in the cloud, we need an online public link. So first of all, we're going to save, and then we're going to go in to our collection and go to share and get the public link. So I'm just going to show you that very quickly. So click save, and then highlight over the collection that you've created, use the arrow and click share, which is here. Then click get a public link on this button here and get this link. So this is now a public link that our Docker containers are able to use. I'm just going to save that. So you can click the copy here. So that's what we're doing there. So then in Windows PowerShell, we're going to run this command. So run -t for terminal, Postman /Newman_Alpine33. That's just the name of a Postman link. And then the link to your tests. Isabel, have you created your own Postman link? Okay, were you following the Postman bit? Because if not, what you can do is you can use this link here, this public link, so you can use my one. But it's good to practice using the Postman side of things as well. If you go back through the recording, or Billy and I can share the slides, you can practice doing that bit, because it's good to be able to build up the tests for using in the future. So we're going to use this command here. So run -t in a terminal. This is the name of the image. It's a Postman one running on this type of Linux, and then run, and then the link to your tests. So let me do that now. So run -t Postman /Newman. Ooh. This is what you see, I can't actually type. Alpine33, run, and then the link, and enter, and then drat. Why is that? Check the spelling of the name. Did that work for anyone else? Oh, Docker run. Yes, thank you. That makes a lot of sense. Ha ha ha. This is because I didn't highlight these things for myself, and then I'm not looking at them. Docker. There we go. So what that's going to do now is that's going to spin up the Postman image for us and run the tests that we've created in that link. And that might take a little bit. There we go. So there we go. We've run 4 tests. We've executed them all. None of them have failed. So these are the results here. So it gives us the name of the tests, what was run, and then all the assertions and how many have failed. When you do get failures, you sometimes get things like this that come out. Any failed tests like come out after it as well. An access denied error. Interesting. Would you be able to share that with me at some point, Shay? And I'll have a look into why that might be. It could be that you're not running your PowerShell terminal as an administrator. But yeah, cool. So yeah, so that's the first test tool that we're using. So congratulations, everyone that's been able to get to this. You can now start doing some API testing using the cloud, which is brilliant. What we'll do next time is we'll start using Selenium and more complex test tools. And we'll also use an orchestration tool to set up all of our like all of our architecture and our test environment, and make it much easier for us to just spin it all up and down rather than running all of these really lengthy commands. But yeah, it's really an easy tool to get started with. It's not scary at all, and hopefully you've got something out of that. And I'll ask Billy to detail when the next session is, and we'll follow on from here, and we'll get a bit more complex with our testing. But yes, well done, everyone. Thank you.
Cheers, Callum. I think it's fair to say it was really good teaching there. Broke it down really simple for everyone, and just looking at the comments to see people follow along really smoothly, and you help with questions as well. So thanks again for getting involved in Quality Advocates. Thanks for everyone for coming along. The next session, I believe, is next Friday at 12 o'clock. And I'll make sure I share this recording prior to that. So if anyone wants to go over anything, I'll share the slides as well in preparation, then they can do so. So yeah.
Just to confirm.
Thursday at 12 o'clock.
So just to confirm, is that the 8th or the 15th?
It's 14th of May.
14th.
Next Thursday, sorry, not next Friday. But I'll make sure everyone gets the video and the slides prior to the 14th, just so they can go over it once more if they need to. But thanks again, guys, for coming along. We've got a number of different events happening this month, so be sure to check out Quality Advocates. And thanks, Callum, for leading today's workshop. Awesome. Thanks very much, guys. Have a nice day.
Bye, everyone.
Bye.